Hi. It's my pleasure to host this 8th annual Equator lecture, or almost annual. I just briefly want to say a few words about Equator, although I hope most of you know about it, and many of you will have visited our stand next door. But we set up the Equator Initiative in 2006 to help to improve the reliability and value of medical research, or the literature, by promoting good research reporting, trying to improve the accuracy, clarity, completeness and transparency. And here we are, sort of 12 years, 13 years later, and it's quite clear there's a lot more work to do. We set it up because we saw widespread deficiencies in research reporting, and that although several reporting guidelines existed, they were perhaps difficult to find and rarely used. Basically, I'm not going to go through all the details because I know it's been a long day and we want to get to hear Patrick. But the core program of Equator is to raise awareness of these problems and the existence of helpful resources, and indeed to provide those resources on our website in particular, to ensure that people have easy access to reliable, up-to-date resources to help them write their papers. And I should just mention that Equator, although you may think of it only about reporting, we are also very interested in guidance for research conduct, but we haven't done a great deal on that as yet. We also develop education and training programs. That's our website, the front page, and it links very quickly to, in particular, the block in the middle, to the most common reporting guidelines. And you shouldn't be put off by the fact that there are nearly 400 reporting guidelines. Most of these are very specialized, and really the core guidelines probably are somewhere between 15 and 20. We've had, since 2006, we've had 7 annual lectures, so you'll see what I mean when I say it's not quite annual. Those are the people who've, I'm not going to name them, but 3 of them are here. Those are the previous 7. The 8th person to deliver this lecture, sitting on my right, is Patrick Bossut. He is Professor of Clinical Epidemiology at the University of Amsterdam. He's also head of the Division of Public Health and Clinical Methods in the Academic Medical Center in Amsterdam. He studies, in particular, the effectiveness of clinical interventions and helps to translate study results to recommendations for practice. He's, in particular, known for his work on diagnostic research, I think, and he leads the biomarker and test evaluation research program in Amsterdam, which aims to appraise and develop methods for evaluating medical tests and biomarkers. This is a large part of the medical literature which has had very little coverage thus far at this meeting. Anyway, Patrick spearheaded the STARD initiative, which is a reporting guideline aimed at obviously improving the reporting of diagnostic accuracy studies. And we're going to hear quite a bit about that in a minute. Lastly, Patrick chairs the Scientific Advisory Committee of the Dutch Health Insurance Board, which oversees the National Healthcare Benefits Package. So you'll see it's quite a wide variety of really important activities. It's my great pleasure to hand over now to Patrick to deliver the Equator Lecture.
Thank you. Well, thank you, Doug, for that kind introduction and for the invitation to present the annual Equator Lecture and to follow these highly esteemed and respected colleagues. My disclosures, I'm a committed consequentialist in test evaluation. It's all about the consequences. But I think I have no actual potential conflict of interest in relation to this presentation or the test that I will mention during it. So As Doug said, I work in Amsterdam, unfortunately not in the city center, in the beautiful canals, but south to the center in this university medical center. And I arrived there 26 years ago, and what I'm doing inside is work with all kinds of clinical specialists to run trials, randomized clinical trials and otherwise, to find out about the effectiveness of interventions. So most of what I do is not about diagnostics, it's about other trials. But the problem was that when we were thinking about studies to evaluate medical tests, we found out many, many years ago that we lacked proper methods, that it was very difficult to come up with the right study design to show that medical tests actually improved patient outcomes and that they were efficient. It's not just imaging, it's lab medicine, pathology, all kinds of markers. So if we ask ourselves how to evaluate medical tests, we basically have three sets of questions. And the first question is this test trustworthy? Is a 12 really a 12? Is a sign read by a radiologist also read by his colleague? And these are questions about the analytical or technical performance of a medical test. But more important is whether the 12 means anything. Is a 12 meaningful? And does the sign carry any clinical information for the clinician? And these are questions about the clinical performance of medical tests. And the bottom line and probably most interesting question is the test helpful? These are questions about the clinical effectiveness of medical testing. What I'll be talking about today is clinical performance of diagnostic tests, so about diagnostic accuracy. I will briefly sketch why and how we developed START, and then discuss the probably interesting question about whether START was effective. We will discuss the update of START, and I will discuss the side effects of START, so what a reporting guideline can do beyond being thrown at authors by editors or by reviewers. But first a bit about diagnostic accuracy. And to use an example, I will use pulmonary embolism, which is a potentially fatal condition for which there is effective treatment, but it still lists as number one in the lists of missed diagnoses. So it can be missed with fatal conditions. Now we'll focus on one family of tests, and they are called D-dimer, and it's a fibrin degradation product, so protein remains of clotting, and when it's present, it could signal a pulmonary embolism or more general thrombosis. Now in diagnostic accuracy, we ask ourselves the question, how good is this test in correctly classifying patients as having the target disease? That's the question in diagnostic accuracy. But most cases, we're not interested in disease in general, but a specific target condition. And to answer that question, we designed a diagnostic accuracy study. That means that we will look at the medical test, D-dimer, and try to compare it against the gold standard, which is the error-free method for finding out whether patients have the target condition. Now, in most cases, including pulmonary embolism, there's no real gold standards. We have to do with a clinical reference standard, and that's the best available method. It may not be error-free for finding out whether patients have the target condition. And the structure for pulmonary embolism, in most cases, the clinical reference standard is imaging, and most hospitals will rely on CT imaging. So a diagnostic accuracy study is quite simple. It means that we take a series of patients in whom we suspect the target condition. They all undergo the index test, they all undergo the reference standard, and then we simply compare the two. And if the test is positive or negative, and the reference standard present or absent, it's a simple 2x2 table. Here's an example of a diagnostic accuracy study of D-dimer in its ability to exclude pulmonary embolism, published in 2016. And the results of this study, like most diagnostic accuracy studies, can be summarized in a 2x2 table with the true positives, the false positives, the false negatives, and the true negatives. And from these 2x2 tables, we can calculate the measures of diagnostic performance, the measures of diagnostic accuracy. And the most familiar ones are the sensitivity and specificity, so the percentage of disease correctly classified as such, and the percentage of non-diseased patients without pulmonary embolism correctly classified as such. But we can also calculate predictive values, and in this study, the authors were especially interested in a negative predictive value, so the proportion of negatives who didn't have the target condition, and that was 99.8. But we can also calculate likelihood ratios or diagnostic odds ratios and 24 other statistics, but that's not the topic of my talk. The topic of my talk is the following. When I first took courses in study design, I learned that sensitivity and specificity are fixed test properties. And I was even invited to write a book about the sensitivity and the specificity of all tests in lab medicine. Now that's complete nonsense. Actually, they're not fixed. Actually, they're in fact extremely variable. And to highlight that, I will give you a few examples about D-dimer. And these are the D-dimer results in patients who didn't have pulmonary embolism. And what you see are the mean values across age groups. And the mean values actually rise with age. And that means that in patients who don't have pulmonary embolism, the number of false positives will increase in elderly people. So you will have a lower specificity in elderly people. It's not constant, it varies with age. It not only varies with age, but it varies with more elements. This is a plot in ROC space, because D-dimer can be a quantitative test, and then you have multiple combinations of sensitivity and specificity. The dots in this plot correspond to the recommended threshold by the manufacturer, so high sensitivity and mediocre specificity. And this is a study in which they compared two D-dimers from the family. Now, the authors performed the study in outpatients, but they used the very same tests in a series of inpatients with suspected pulmonary embolism. And the results are shown actually in this slide. And what you see is a dramatic decrease in specificity, so far more false positives in inpatients than in outpatients, with the same tests, the same investigators, same protocol. And it's not difficult to see why, because the false positives are generated by the other conditions for which the patients are in hospital. So it matters if you evaluate the tests in inpatients and outpatients. But there's even more. So in our hospital and many others, they rely on a clinical decision rule. They look at the signs and symptoms and classify patients as having a low probability of pulmonary embolism, medium, or a high probability. But let's just count signs and symptoms and see how D-dimer does in the respective groups. So here again you see a plot in ROC space, the combinations of sensitivity and specificity for patients with 0 of these items positive, so no signs and symptoms that suggest pulmonary embolism. Yes, that happens. For example, if D-dimer is tested routinely in the emergency department, 1 item positive and 2 items positives. And again, you see a dramatic difference in specificity. So the specificity is much lower and significantly lower in those actually that have more signs and symptoms that suggest pulmonary embolism. And the specificity is about 50% in those who don't have a suspicion for pulmonary embolism. So we see that these elements vary, and that means that if you do a systematic review of tests of D-dimer in suspected pulmonary embolism, you get pictures like this. So there's random variability, but a lot of the variability is true heterogeneity because the test was evaluated in different patients, different settings, and maybe also because there are different D-dimers. Now, if we read a study about D-dimer, what do we know about the patients that were in the study? Well, the truth is, not in most, but in many studies, we don't know much about the patients that were included. So these were results from an evaluation in 2000, and where we looked at the inclusion and inclusion criteria in the setting, and it was mentioned in about 1 in 4 papers. So 3 out of 4 articles never mentioned the eligibility criteria, and they actually, 1 in 2 didn't even tell us whether they were males or females, or whether they were young patients or elderly patients. So these authors believe that sensitivity and specificity are fixed, so they don't need to tell us where they evaluated them. But there's more actually in diagnostic accuracy studies. We have variability, but we also can do studies with deficiencies. For example, this is the typical study. All patients with suspected pulmonary embolism undergo D-dimer and then CT pulmonary angiography. But in some studies, the authors include, for simplicity, patients with massive pulmonary embolism and healthy controls. For example, first-year medical students who are invited to contribute to science. And then they estimate the specificity in the first-year medical students and the sensitivity in patients with massive pulmonary embolism. Now, there could have a reason for that, but the sensitivity and the specificity will not reflect actually the behavior of the test in clinical practice. Sensitivity will be too high and specificity probably also too high. But there are other deficiencies as well. For example, in many studies, we will not have this picture, so a full 2x2 table, but some patients will not undergo the reference standards. And that could be for random reasons, and if it's just random, then we have, for example, half the patients have the true positives, and we will have less precise results, but no real bias, no systematic bias. But in most cases, the patients that undergo the reference standard will be distributed differently across the 2x2 table. There will be more positives who undergo the reference standard than negatives, and more patients with the target condition than patients without the target condition. Now, if we estimate sensitivity and specificity based on these results, we miss the false negatives, and we will overestimate sensitivity. And we also have bias in specificity. So if all patients undergo the reference standard, we will introduce bias. Now, a potential solution, which was also used by the authors, is to use follow-up. See if anything happens, for example, in negative patients. And if nothing happens, a negative is called a true negative. But if the patient is admitted to hospital, he is called, and pulmonary embolism is found, he's called a false negative. So now we have a reference standard in all patients. Some have imaging, and the others have follow-up. And it seems that we've reconstructed a full 2x2 table. But it's not exactly the case, actually, because that only applies if CT and follow-up are interchangeable. And it's very likely that not all patients with a lesion, with an embolus on imaging, will have an event if left untreated. Actually, some will resolve by themselves. So that means the two results are not interchangeable, and some patients who would have been classified as pulmonary embolism based on imaging are classified as no pulmonary embolism based on follow-up. So the 2x2 table is reconstructed in the following way that we will have, if we see it in a minute. Ta-da! Yes. No, that's okay. In the following way, so we have the false negatives are now classified as true negatives, and we will overestimate sensitivity and overestimate specificity if we use two different reference standards. And you can say, Patrick, that's all very well, but these are all anecdotes. Does it really matter? Yes, it does, because we compared studies with complete verification, one reference standard, and studies with two reference standards, and studies using healthy controls, and studies using a single series of patients for the same disease, the same test. And what we found out is that there was empirical evidence for a systematic bias in these kinds of studies. So in our comparisons in studies with deficiencies, in studies without deficiencies of the same test, we found evidence of a systematic bias. And the two features that stood out were the use of healthy controls and the use of different reference tests. This was a very difficult study to do because in most cases the things were poorly reported. So we had to do an independent scoring of the articles in different rooms because we had to limit the amount of strong language that was typically used by one scorer who could not find the necessary information, whereas the others was also cursing because the information was finally found to be found in the discussion section. Now, Jeroen Leimer, who did this study, came up with the idea for a reporting guideline. Actually, it was not part of my initial plan, because Jeroen Leimer went to the Cochrane Colloquium in Rome, if I'm 99, if I was correct. And there he had a discussion with David Moher, and I think also with Drummond, but I'm not sure about that. And they say, we should develop a reporting guideline, because the logic is very simple. If the information is crucial and often not reported in the articles, there should be a consort-like reporting guideline for diagnostic accuracy studies. So let's try and develop one. So we assembled a steering committee that included Jeroen, but also Drummond and David. And David Bruns, the editor from Clinical Chemistry at the time, Constantine Gatsonis, a statistician, Les Urwig and Paul Glasio from Australia, and other colleagues listed on this slide from Amsterdam. And we started preparations for a meeting, a consensus meeting, and the preparations included developing a long list of all the items that had been suggested as essential in reporting these kind of studies. And these were in total about 130, 140 items. And then we assembled a group of researchers, editors, people from professional organizations, funders, methodologists, whom we invited to the consensus meeting. And to our relief, actually most people agreed to come. Only the ones I indicated with a star actually were not able to make it. And that may have to do with the dates of the consensus meeting, September, and also with the location, because what better city to organize a consensus meeting than Amsterdam? Actually, very few people could resist the temptation actually to visit Amsterdam for this meeting. So I think they were convinced of the importance of the consensus meeting, but the location helped. Then where in Amsterdam? Well, most people would be arriving at Schiphol Airport, so we selected this beautiful hotel, which was very conveniently located near Schiphol. But then we had made all the bookings, and they said, well, this is not possible. Actually, you invite people to Amsterdam, and then you have a consensus meeting in this bland hotel. No, that's not possible. So at the very last minute, the rooms were already booked. Actually, we also booked this magnificent building in the city center of Amsterdam. It's the house of the Royal Academy of Science. And both mornings, it was a weekend consensus meeting, there were small vans actually moving all the people to this building in the city center. And it really is a magnificent building with all libraries and carpets and so on. And it had the desired effect, because we invited people to the consensus meeting, and they were so impressed by the building that they kept silent the whole morning, and we made great progress. But in the afternoon, actually, people got used to the building, and they said, wait a minute, I didn't come to Amsterdam actually just to sign at the dotted line. So we had very heated discussions about the items that should be in the consensus guideline. And actually, the only solution actually to end these discussions was to have a dinner in this beautiful building nearby with French wines and Belgian beer, and the dinner lasted all evening. And during that night, a couple of us stayed up and developed a consensus. And on the Sunday morning, everybody was very happy to see the consensus after that wonderful dinner, and agreed with the consensus and left. And the consensus was piloted for more than a year, and eventually, you can see it on this slide, it was a single-page checklist of essential items that should be reported in diagnostic accuracy studies. And it included, for example, had an invitation to report about the participants. So tell us the eligibility criteria, but not just the eligibility criteria, but also tell us where you found the eligible patients. How did you identify them? And where then identified? What was the setting? And please give us the dates. And were they a consecutive series or a random convenience sample? So these items were part of START. And after piloting and testing, the START checklist was published in 24 journals, thanks to the generous help of the members of the steering committee and the members of the START group. So 24 journals published it in January 2003. And actually later we invited journals to endorse START, and that led to a long list of journals who wanted to endorse START. It also was translated in many, many other languages. A few of you can see on this slide. So we're very happy with that publication in 24 journals, but the critical question is, well, did it have any effect actually after the publication? And there have been before-after studies. And this is the general conclusion. Yes, there are some improvements after 10 years of START. In actual fact, there's even a systematic review of all the before-after studies. And here you can see the results. It's a bit of a busy slide, but on average, the mean change is that there's one more item reported after the publication of START. Fortunately, it's a significant gain. It's interesting to see what the distribution is of articles that report multiple items, and that's shown on this slide. So you see the percentage of articles in the evaluations, in a couple of the evaluations that report the number indicated on the x-axis. And the median number has changed over the year, but if you see the three curves, you see that there are more articles publishing more items, but that the gain is mostly at the bottom. So there are a couple of articles that seem to adhere to START quite substantially, but there are also small pockets of resistance, actually on the top of this slide, so items that just by chance maybe mention a few, articles that mention a few of the items, but still fail to include essential information, such as eligibility criteria. So yes, there is change, but it's going very, very, very slowly. This slide, for example, mentions the items that I mentioned earlier, so please tell us the inclusion-exclusion criteria. So in 2000, it was 1 in 4 of the articles. But fortunately, over the years, it's now actually has grown to about 65 of the percent of the articles. So more and more people think that it's good to report what the eligibility criteria were for the study. And the improvement is also there, but less pronounced in the other elements of the START checklist. So I can write as a tutorial, I think every year, there's still room for improvement in the reporting of diagnostic accuracy studies. And one of the reasons for the room of improvement is the rather loose language that is used in the instructions to authors. This is a somewhat older list, but it lists the wording that is used in the instructions to authors by the respective journals. So some journals say that you must use or should reflect the reporting guidelines, but other journals say, please refer to the reporting guidelines, or please use the reporting guidelines. So rather loose language, and that hasn't changed over the years. So it's still it's still optional for many journals. After a number of years, we decided to update START, and I think the rationale for START, the update, also changed. What we wanted to do, despite the original Python, is improve the ease of use, because we found out that authors still found it difficult to use the guideline. They were also confused because some of the language used in START differed from the language used in CONSORT. So we use different wording than Doug and David and the colleagues in the CONSORT team, and maybe that's confusing. So why not harmonize the expressions? We wanted to include new evidence about sources of bias and limitations in applicability, variability. We also wanted to include other issues that became more important in reporting, like issues related to integrity. And you heard about SPIN yesterday. This is a study of SPIN in diagnostic accuracy studies. And what impressed me actually were these numbers. In diagnostic accuracy studies, 90% of the studies that we analyzed, the random sample, did not have a sample size calculation. They did not have a test hypothesis. Actually, the majority did not report the imprecision out the estimates. And about 1 in 2 did not specify what the test was going to be used for. Now, if you don't know actually what you're studying, you can make any conclusion about your article. So it's no surprise that there's so much spin, because these elements are not specified in many articles. And that's why the revision of SPIN also includes a number of other elements, trying to limit, the revision of START tries to limit the amount of SPIN by asking authors some of these additional elements. I'm also skipping this. Now the START group was accused of being a bit too inclusive, too small in 2000. So what we did is extended the START group. The START group now exists of 85 people, and includes multiple stakeholders. It includes funders, medical journalists, clinicians, and an increasing number of methodologists. Unfortunately, we did not include patients and some other stakeholders that are sometimes mentioned as necessary participants in the reporting guideline development process. And with these 85 people, we had a Delphi procedure and again a consensus meeting in Amsterdam with a smaller team that was making the necessary judgments, final judgments about the inclusion and the revision of START. And you can see some of the usual suspects on this slide. So the update appeared in 2015, not in 24 journals, but in Clinical Chemistry and Radiology and the BMJ, actually 3 journals that strongly supported START from the beginning and that reach out to different audiences. It still is a one-page checklist, so we removed items, simplified items, and added a few others. So START had a limited effect on the number of items reported, but did it have other effects? And while preparing this presentation, I started to think about these other effects, and I think that reporting guidelines should not be judged by the number of items that are mentioned in the articles. One of the benefits is also to improve the terminology. So the terms that are used for describing diagnostic accuracy study. Here is a study that I mentioned in the beginning, the study of D-dimer in suspected pulmonary embolism in 2016. The study does not mention START. Actually, there's no reference to the reporting guideline, but nevertheless, it uses the word diagnostic accuracy. And it's not alone. The term diagnostic accuracy is now increasingly being used for this type of study. There was no such term in 2000, and diagnostic accuracy had another meaning, usually the number of patients correctly classified in total. By the way, such increased number of hits in PubMed should always be corrected for inflation. And there you can see that START actually hardly made a dent in itself. But if you look closely at the more recent publications, then you see that it's used for this type of study. There are other elements in the terminology that have been influenced by START and in the reporting. So this study does not mention this reporting guideline, but it includes a flow chart. One of the elements that was recommended by the START reporting guideline. When we developed START, only 2% of studies included such a flow chart, and the number has now risen to about 40%. And because diagnostic accuracies can sometimes be very difficult in terms of the flow of patients, we believe that such flow diagrams can be very helpful. There are other terms as well, like the reference standards, which is now increasingly being used as the replacement for the gold standards, and the target condition. Target condition is also a term that's increasingly being used not just in the, in the reporting guideline, but also in many articles, the condition that we try to identify with the diagnosis. But there's more terminology needed. You can always recognize a field in the debates about the terminology. For example, in the types of studies. So I presented the basic study as one that included all suspected patients. And then you have on the left the cases and on the right the non-cases, the patients with and without the target condition. And they're probably different severity. So a single set of inclusion criteria and a single definition of disease. But we also have these studies with extreme phenotypes. And we have no good label for calling these studies anyway. So they're sometimes called case control studies, but that's an insult to the epidemiologists because they're not really case control studies. Even if they include healthy controls, case control studies would be a subsample of the cases and the controls and not these extreme phenotypes. So we need more terminology. Now, START is also used in teaching, and increasingly we get emails from people that tell us that the explanatory document is their key resource in teaching diagnostic accuracy studies. So this long document is not just used by authors who want to evaluate the completeness of their reporting, but it's also used in teaching diagnostic accuracy studies. And the elements of START also appear in quality appraisal instruments, like this risk of bias tool for diagnostic accuracy studies, who builds on the things collected in START. Now, START has also been the starting point, no pun intended, for other initiatives. We've developed a START for abstracts, which appeared in BMJ recently. And we also developed a checklist that can be used for including a diagnostic accuracy study in clinical trial registries. Because we believe that diagnostic accuracy studies, most diagnostic accuracy studies, are also trials and should be registered before they started for the very same reasons that we expect randomized clinical trials of pharmaceuticals and other interventions to be included in trial registries. And while many of the registries were not developed for diagnostic accuracy studies, our article in Clinical Chemistry shows that it's not too difficult to use the existing fields to include the necessary information building on START. And we will also develop START for protocols in the very near future. So what about the future? Well, I think that we were extremely naive in 1999. We believed that we could change the world with a manuscript. That the only thing that we needed was a paper, a checklist, and publication in 24 journals, and the rest would follow. What we didn't think through enough in 2000 was our plan actually to change the reporting. So how and where will authors find these documents? When will they learn about it? At what stage in the review process is it necessary or most efficient to use these reporting guidelines? I believe now that the reporting guideline is never the end product, but that the list of essential items that was developed in 2000 and in 2015 is only the beginning of a larger campaign that probably will last my lifetime, if not longer, to improve the reporting of diagnostic accuracy studies. Because it's still necessary, people rely on the information in articles to make decisions, and they should find all the necessary information without spin in the reporting, of such diagnostic accuracy studies. Thank you very much for staying so long for this presentation, and happy to answer questions. Thank you.
Okay, thank you very much, Patrick. Yeah, we'll go straight to some questions, and over there, please. Hang on.
Equivocal test results?
START deal with what?
Equivocal test results, intermediate, indeterminate, and interpretable results?
There's specific items about the handling of intermediate or unclear results and about the handling of missing data.
Thank you.
Can I ask you whether you've experienced resistance, sort of hostility to the idea? Because we sometimes encounter the idea that you're treading in other people's territory, if you like, and telling them how to do their research, which clearly you're not. Well, yeah. Not explicitly anyway.
Oh, yes. So we've encountered hostility from a number of groups. From journals that you're actually killing the creativity of our writers, of our authors. And we received very hostile papers from journals. The second was from authors that said, actually, you're telling us how to do studies, which is not the case. We invite authors to be clear and complete in their reporting. So just tell us what you do, and then others can judge whether it meets whether the study design meets the research question. We also encountered hostility in terms of terminology. For example, the people in metrology said, how can you use reference standards for an imaging procedure? A reference standard is an infallible reference standard, and a CT can never be a reference standard. Then we explained, no, it's a clinical reference standard. It's what's used in clinical practice. So yes, over the years there was a lot of resistance, but that gradually declined. It's much better now. Yeah.
Okay, great. Yeah, please.
I noticed in one of your slides that you plotted the frequency with which particular items were reported over time, and I saw for one of the items there was a peak in 2004 and then it had actually dropped back. So I guess wondering if you could comment on whether there's any evidence for guideline fatigue, I guess, particularly as, you know, people are being required to comply with increasing numbers of guidelines.
I don't think there's real guideline fatigue. Although I must say, if I submit a paper on a diagnostic accuracy study and the reviewer tells me or tells our team, you did not use START because item 12 and 13, there's a certain sense of fatigue with me that I failed to recognize the necessary items. It happened to me. No, actually, as we heard earlier today in the presentation from Mark Dewey, that actually the introduction of the reporting, the required use of reporting guidelines, for example, in radiology, went rather smoothly. And there was not a massive revolt of authors that all of a sudden took their papers to a different journal. There could be a sense of fatigue in the, but that's a larger discussion and a question for Doug, with 400 guidelines. So how to find them, when to use them, what if they're conflicting guidelines? So yes, in the end, the EQUATOR faces a challenge with the growth of reporting guidelines and there are initiatives to help people to select the right guideline, of course. But I don't think there's a general sense of fatigue.
Perhaps I could just comment. There's a surprisingly little duplication of territory amongst those guidelines. Although they do get more and more niche in the areas they relate to. And as I always say, you know, probably no more than 20 would cover pretty much the whole spectrum. The one area that's missing is laboratory research, not animal research, but wet lab research, which I haven't seen guidelines for, and since I can't understand those papers, I'm not willing to get involved.
Yeah, there are some guidelines for some of those things, I think, and for example, you know, there's, I think the Miami was the first, so minimal sort of reporting information for microarray experiments.
Yeah.
Then there's proteomics. The thing that I've been a bit involved with is the biospecimen reporting, the BRISC tools, and I guess BRISC is an example which has been adopted by a number of journals in terms of people who use biospecimens in research are meant to adhere to Tier 1 BRISC reporting guidelines, but you don't tend to see a lot of it actually in papers or a discussion about how people have done it. I'm about to go to a biobanking conference in Sweden, so I'll be interested to look at to see whether there's been any update on the use of those guidelines in biobanking.
I think most of those guidelines, like Miami, are more focused on the data rather than the study design and the participants and so on. So they're not truly analogous. I'd like to ask the editors. Do you want to ask a question?
Quick question, maybe. David Schreiger, UCLA. I worry a little bit about a different unintended consequence of these things, which is, take pulmonary embolism. You know, it's my belief that we're doing far too many D-dimers, leading to far too many CAT scans to detect pulmonary embolisms that are probably of no clinical consequence. And what's happened to some extent is that the better studies that have been compliant with STAR-D and therefore are thought to be good studies fuel this kind of testing madness. And kind of carry an extra weight because they have the imprimatur of STAR-D and all of this. And what's really missing is careful thought. And that there's this danger that while I agree that complete reporting is important, that all of a sudden completing the reporting guideline and being compliant with it gives it a seal of approval that's beyond what it's worth, and that it acts as a substitute for real careful thought about whether the study results mean what the people would like to think they mean.
Yeah, I agree. And that's why I showed the initial 3 questions, that the bottom line question is whether testing is helpful. And even despite the accuracy of the dimer, in many situations, it probably leads to over-testing. And there are some concerns about an overuse of CT scanning because of positive D-dimers, even in my institution. So yes, accuracy is only a small bit in the total, actually, decision-making about medical testing. I don't think that the studies themselves stimulate overuse. I think it's more difficult, and that the START seal of approval would encourage the use of the test. That's a very strong accusation.
It's not so much an accusation, it's a concern that as we become I mean, there's an advantage to standardizing things. There's an advantage to making lists of things that are important. But there's a danger in that, which is when that begins to substitute for careful thought, there's an unintended consequence. And I just raised that issue.
I agree.
Not just with STAR-D, but with all the guidelines.
Yeah.
Yeah, Hal?
Perhaps I missed this, but are studies of diagnostic test performance getting better sort of in parallel with relatively non-use of the guidelines? Is it getting somehow baked into our DNA to do it right despite non-use of STARD and other guidelines?
Yep. Well, thank you for saying that, because I was so concerned about time that I missed that point. So what I see is that gradually things are getting better. So from our systematic evaluations of the literature, we see improvements. And we see improvements by, that's why I showed the study, with people that don't refer to STARD. But in general, I think there's a better understanding with reviewers, with authors, and with scientists about how these studies should be done and how they should be analyzed and interpreted. And my belief is that STARD was not the causal factor that changed all of that, but was one part of, and probably, I hope, helped to achieve that change. I don't think it's a spontaneous change of the DNA of researcher. I think it's the efforts of a lot of people that are teaching study design to junior researchers in lab medicine, in imaging, and in clinical medicine in general.
Change is complicated.
Yep.
I'd just like to note that you published both versions of STARD in multiple journals. I think the first example of that was the Consort 2001, which was published in 3 of the leading general medical journals simultaneously. I think you probably hold the record with your 24. I think I haven't got anywhere near that in my papers, but I just wondered if any of the editors wanted to comment on the pros and cons of publishing the same paper in multiple journals simultaneously, which I guess is designed to reach multiple audiences in this sort of super connected world now, PubMed and the internet and so on. And I've heard conflicting views, but just to go on, I was trying to provoke somebody.
Trish Groves and Elizabeth Loader will rescue me too. Fiona Godley, BMJ. Yeah, it does occur to us that this is a bit ridiculous still to be doing it, but the awful naked truth is that these checklists are highly cited. So actually, you're in a seller's market when it comes to them. And I guess, I mean, I don't know if Elizabeth and Trish or anyone wants to contradict me. They've all gone, just in time. Or maybe Christine Lane is here. No, I'm alone. There we go. That's my honest truth. Drummond, your hero. I hope you're going to support me in this.
I support you in everything, Anne. However, coming to this, I was there and you asked this question, and the idea, of course, was simply to have Anthony Proto as a step, as a radiology journal editor, to help with the buy-in of all the radiologists doing their tests, to have David Bruns in clinical pathology for the same reason. A big effort was made like that. I feel it was really important.
Sorry, excuse me, can I just add something else? One of the crucial things about these guidelines is that they be freely available, open access. And I do think, you know, I'm going to just say for the BMJ, all of our research methods and reporting articles are open access. So I think if you're going to go for one journal, go for an open access journal.
Okay, thank you.
That's true, yeah. And also the STARD update was explicitly released under a Creative Commons license that allowed for reuse and distribution, which was not the case in 2000. So the copyright, for example, for the 2000, despite the fact that it was published by two dozen journals was a bit vague. So I think it's a big bonus that we make it explicitly available for not just the articles in open access, but the checklist are freely available.
Okay, the final question.
It's more of a comment. I am a radiologist, Debbie Levine. I can kind of speak for Tony Proto because I was there at the time. And it was really important to reach the different subspecialties that don't always cross-communicate. We didn't have internet access the same way now to articles from other journals in 2003 that we do now. And I think that even though we'd like to not have duplicate publications, sometimes there's articles that are so incredibly important that you want different subspecialties to have the buy-in from their groups. And so I would say that it is okay still to do it in more than one journal.
Okay, thank you.
I think the leadership of radiology in the imaging field and of clinical chemistry in the lab medicine field were incredibly important at the time. And that they agreed that this single checklist was also to be used in other areas. That was terribly important.
Okay, brilliant. Thank you very much, Patrick.